In this tutorial, let's look at what is Miller's theorem. So basically, we have two input terminals whose voltages are V1 and V2 connected by an impedance Z. So there can be another circuit below this as well. That means, so in general I can represent it like this as well. Okay, so this is ground and this is also ground. This is V1, this is V2. What the theorem says is, given K is equal to V2 by V1, we can represent the same circuit with another form, in which you can represent the circuit with these transformed inductances, sorry, transformed impedances. So this Z is equal to K by K minus 1. So let us see how can we prove this circuit in the first place. So I have a circuit like this, and its voltage is V1, here it is V2, this is Z. Equivalently, I can represent the same with a circuit of this nature, because from the terminals it doesn't matter, right? Z, and this is V2, and this is V1. Still the terminals, when you see from the terminals, if I just cover it up in a black box, you cannot see a difference between these two circuits, because it is V1 minus V2 divided by Z here, and this is also V1 minus V2 divided by Z. That is what the current is coming out. So here we'll try to apply the source transformation technique here. So from this we can apply source transformation technique. So the impedance will come in shunt, and the voltage source becomes the current source, which is equal to V2 by Z, isn't it? That is equal to K into V1 by Z. Since we have earlier defined the relation as V2 by V1, right? Yeah. So, and similarly the other part we can apply source transformation and represent it by V1 by Z is equal to V2 by Kz, right? This is V2, this is still V1. Now, according to the source absorption theorem, we can still further represent the above circuit like this. Why? Because V1 we are representing in V1. That means, so let's check whether this is right or wrong in the first place. So let me give you the actual transformation using source absorption theorem. Without giving the statement for the theorem, let's check whether this is correct or not. Can we write the above circuit in the following fashion? That's a question now. So basically, what is my from the what is the basic? From the terminal, it should appear the same. So it is just V. If I write the equation for current, what would be the equation for current here flowing in this node? Would be V1 by Z plus V1 by minus Z by K. Isn't it the same? It is the same, right? So here it is V1 by Z plus this is the negative current that is entering into the node. So we are just playing with algebra, right? So this is not that difficult to digest. So once we have a circuit like this, we can club them into two parallel networks. So equivalently, it's interesting to note that the circuit which we started with had end up in a different form.